So hello everyone. I hope you all have attempted the part test 4. So now we are going to discuss the solutions of part test 4. My name is Prachi and I am working as a research associate in CSIR NML lab. So let's begin with the solutions for part test 4. Okay? Yeah. So for chemistry, the question number 51, there is a diagram given here. On the basis of the figure given above, which of the following is not true? Let's look upon the options. In figure A, assuming the state of dynamic equilibrium, rate of gaseous particles entering and leaving the solution phase is same. In figure B, on compressing the gas, number of gaseous particles per unit volume over the solution increases. Rate at which the gaseous particles are striking the solution to enter it decreases. And the fourth one is the rate at which gaseous particles are striking the solutions to enter it increases. So the correct option will be option C. The rate at which the gaseous particles are striking the solution to enter it decreases. But why it is so? So as the pressure, okay, so as the pressure increases, which will be due to the compressing of the gas, the number of gaseous particles increases. Okay, the number of gaseous particles will increase and the solubility will accordingly increase until a new equilibrium is developed. Okay, so the pressure of the above solution will increase on increasing the solubility, which will be confirmed by option number 3. Okay, the rate at which the gaseous particles are striking the solution enter it decreases. So this will be the correct answer. Let's move on to the next question. Question number 52. Which process is used to manufacture freon from tetrachloromethane? Okay, so freon, what will be the structure of freon? Here it is ClCl and here it is F and F. Okay, so this is FREON, freon. It is also known as CFCs. Okay, so in the Stewart reaction, how it is formed from tetrachloromethane. Tetrachloromethane, we all know what will be the structure. 4 chlorines are attached. Okay, so this is tetrachloromethane, and from tetrachloromethane we have to form the freon, which is the CFCs. By Stewart reaction we can do so. Okay, so the Stewart reaction will be the correct answer. In question number 53, the complex COEN whole 3, CrCN whole 6 and CrEN whole 3 and COCN whole 6 are examples of. Okay, so what are the example? It is a direct question based, direct concept based. So let us first okay, let's see. Only the arrangement of ligands are different in these two. Okay, the arrangement of ligands here, for CO the En is attached, 3 En ligands is attached, and for chromium 6 CN ligands is attached. Okay, for chromium in the next 3 En ligands is attached, and for the cobalt 6 CN ligands is attached. So what are the so these both are the example of which type of equilibrium, which type of isomerism? It will be coordination isomerism. Okay, because only the ligands are interchanged but the central metal atom remains the same, which is the example of coordination isomerism. Okay, for question number 54, match the column 1 with column 2. Okay, so this is the direct theory based question. Okay, you have to only remember the examples. So let's see, the thermal decomposition of HI on gold surface. So this is a type of zero order reaction. Okay, the inversion of cane sugar is a pseudo first order reaction. the hydrogenation of ethene. Hydrogenation of ethene is a first order reaction, and the decomposition of gaseous ammonia on a hot platinum surface at high pressure is a zero order reaction. So on matching all these, which will be the correct option? Option number C. Okay. For question number 55, which of the following amino acid possess two chiral center? Okay. So let's see the structure. First, let's see the structure of threonine. So for this, we should know the structure of threonine. Okay. Otherwise, we will not be able to find the chiral centers here. So this will be the structure of threonine. It is of biomolecules chapter. So we have to remember the structures of some of the most important compounds. Okay. So this is the threonine, and we can clearly see that this carbon and this carbon is chiral carbon. Why it is chiral? Because four different groups is attached to this carbon, and if we draw the mirror image, they both will be non-superimposable. Okay. They both will be non-superimposable. So they both possess two chiral centers. So the first option is only correct, so no need to see the next options. Okay. Question number 56. Which of the following will show the maximum number of oxidation state in this compound, in its compound? Okay. So for gold, the maximum oxidation state that can be achieved will be +5. For manganese, the maximum oxidation state will be achieved is +7. For osmium, it's +8, and for chromium, it will be +6. So we can see from here which of the metals, which of the following compounds will have the maximum oxidation state. So it will be osmium, which is of +8. Okay. So the next question, for question number 57, the correct order of thermal stability of the following compound. So the correct order of thermal stability. So here see, the stability of Pb plus 2 will be the highest, or say is the greatest, then Sn plus 2 and Ge plus 2. So why it is so? It is because of inert pair effect. Okay, it is because of inert pair effect. So what is inert pair effect? It is mainly observed by heavier main group elements. Okay, and what does it means? It is basically the tendency of the s electrons in the outermost orbit, okay, due to which it remains uninvolved in the chemical bonding. It means that the s electrons which are present at the outermost orbits, they are unable to involve in other reactions. Okay, they will remain uninvolved despite their availability for bonding according to the octet rule. They will not participate in bonding, and so the outer s electrons experience relatively poor shielding from the inner s electrons due to stronger nuclear attraction, which will lead to higher energy barrier as for their involvement in bonding. So as a result, the heavier groups will experience the inert pair effect, due to which what happens? Their stability also increases. Okay, so the correct option for question number 57 will be 3. Okay. For question number 58, how can we differentiate between acetone and acetaldehyde using the reactions? Okay. So let's first draw the structure of acetone. Okay, this is acetone. And what will be the structure of acetaldehyde? CH3, C double bond O, CH3. Sorry, it is H, right? I have drawn the acetone. Sorry for the mistake, okay? So here it will be H. This is acetaldehyde. So for acetaldehyde and acetone, these both contain the carbonyl group, and we know that if these both compounds contain the carbonyl group, then which type of reaction it will show? It will give Tollens test, okay, or it's commonly known as what? It is commonly known as silver mirror test. So it reacts with Tollens reagent. It will be the correct answer for option question number 58. For question number 59, identify the major product. Okay, let's zoom in a little bit. Okay, where it has gone. Just wait a second. We are doing question number 59, right? Yeah, so I have wasted 2 of your minutes. I'm so sorry for that, but sometimes my laptop. Question number 59, yeah. So for question number 59, what is the major product in this reaction? Okay, so this is chlorobenzene, and chlorobenzene on reaction with CH3Cl and AlCl3. What will be the major product in this reaction? So the major product obtained when chlorobenzene react is 4-chlorotoluene. Okay, so which type of reaction is this? We will get the product as Cl and ClCH3. So this is 4-chlorotoluene. And which reaction? What is the name of the reaction? It is Friedel-Crafts alkylation. Okay, so accordingly option 3 will be the correct answer. Okay, so for question number 60, the non-existent metal carbonyl among the following. Okay, we have to find the non-existent metal carbonyl. Yeah, which will not exist at all. Okay, like some of the animals that do not exist in the earth. One of it is the rhino one. Okay, right. You must have heard that only two of it are remaining. So let's find out the other element which does not exist. Okay, let's hope that the rhino doesn't go extinct. Right. So for non-existent metal carbonyl among the following, let's find out what we have to find. We have to find the EN. We have to go according to the EAN rule. EAN rule means the atomic number of metal and the electron donated by the ligand. This should be 36. Okay. If it will be 36, then only it will exist. So let's find out one by one for chromium 6CO. Okay. The atomic number of chromium is 44 and the electrons donated by carbonyl ligand. 6 electrons are there, and there is the carbonyl ligand will have 2. Okay, it comes equals 36. So this will exist. This metal carbonyl will exist. What is the atomic number of manganese? It is 25 plus 5 of the carbonyl atoms ligands. This comes out to be 35. Okay, so we can see that this does not have the 36 EAN. According to EAN rule, it will not exist. Let's see the other two. The nickel has the atomic number of 28 and 4 of the carbonyl group. It will be 36, and the iron have the atomic number of 26 and it has the 5 of the carbonyl group. So it will also be 36. So according to this, the MN1 is the correct option because it does not exist. Okay, it has 35 according to the EAN rule. So for question number 61, it is a direct question. So let's see how direct it is, because sometimes it happens now. You are in the examination hall and you doesn't that that particular theory answer doesn't come to your mind. Okay, so at that situation, don't panic at all. Try to remember as much as you can. But in the meanwhile, try to attempt the questions that you are sure about. Okay, so let's see this question. Number of lone pair of electrons on Xe atoms in XeO2F2, XeF4 and XeF6. Okay, so first let's draw for the simplicity. We have to draw, then we can find the number of lone pairs in it. So for Xc, O2, F2. Okay, so this type of structure is there, and the lone pairs. You have to find the lone pairs only. Okay, so for this compound is sp3d hybridized. Sp3d hybridized means it will have the trigonal bipyramidal type geometry, but it does not have this geometry. Okay, this is the expected geometry. What will be the actual shape? Its actual shape is seesaw shaped. Okay, why the actual shape is there? Because of the lone pair, right? So this has, how much lone pair is there? This has one lone pair. Okay, the next structure is of XCF4. So XCF4 will have this type of structure. We are talking about the lone pair of electrons on the xenon atom. Don't get confused between the lone pair of fluorine or oxygen. Okay, yeah, fluorine will have three lone pairs. Yes. So this structure, this will have hybridization of sp3d2. Okay, and it will have octahedral geometry, and the lone pair is 2. Lone pair of xenon atom will be 2. The next one is XCF6. Okay, XCF6. Okay, so this is XCF6. Draw the lone pair of fluorine accordingly. Okay, so this will have sp3d3 hybridization. Okay, and its geometry, what will be its geometry? It will be pentagonal bipyramidal, and it will have one lone pair. Okay, so according to this, which will be the correct option? 1, 2 and 1. 1, 2 and 1. So option 1 will be the correct option. Okay, we have to find the lone pair of xenon atoms. For question number 62, which compound when heated with KOH plus Br2 yields ethanamine? Okay, ethanamine. So among this, which will be the correct option? The correct option will be option number 3. Propanamide when heated with KOH and Br2 yields ethanamine. Okay, like this. Propanamine, what will be the structure? CH3, CH2, C double bond O, NH2. Okay, this is the propanamide. On reaction with Br2 and KOH, it will give CH3, CH2, NH2. This is ethanamine, and byproducts are there. Byproducts are KBr, K2CO3 and H2O. Okay, so correct option will be propanamide. Let's move on to the next question. Question number 63 says, the plot that represents the zero order reaction. Okay, so for zero order reaction, we have to see the rate. Rate will be K, concentration of R at 0. The rate will be, okay, so this will be the equation for zero order reaction, and here the concentration of the reactant and time is equals to T. At zero order reaction, the time T we will take, and hence the R decreases with time. So if the R decreases with time, if the reactant decreases with time, what it concludes? It concludes that this option, the R decreases with time. Okay, so option 3 will be the correct one. If it comes out to be increasing, then option 1 will be correct. So in this case, option 3 is the correct option. Question number 64. So for question number 64, the product of the following reaction, this on reaction with OH minus and heating what is the product that we observe. So in this case, aldol reaction will take place. Okay. So what happens in aldol reaction? I will need some space for describing the okay. So for aldol reaction, this is what is the name of this compound? This is cyclohexanone. Okay. So cyclohexanone on treating with OH minus, what will happen? Two of the cyclohexanol are required because aldol condensation is taking place. Condensation means two of the molecules are combined together. Okay, this is the meaning of condensation. So what happens? This type of product will be formed. Okay, this is not the product, but okay, here will be H and here is OH. So upon heating, what will happen? Upon heating, this hydrogen and this OH will be removed as water molecule, and what we are left with? We are left with this compound. Okay. So among this answer, what is among the options? Option 2 is the correct one. Okay. So the next question. What is option B here? Okay. Option B, chloromethane on reaction with AgCN gives a molecule A, gives a compound A, and on reduction it will give B. So we have to find the B here. What is B? So what happens that Ag and Cn, okay, we know that the Cn has negative charge. So what it will do, it will react with, it will attack here and the chlorine molecule is removed. Okay, the chlorine molecule is removed and the Cn minus will be get attached to the CH3. So CH3Cn. This compound is the option A, which on reduction. So what happens on reduction? We will get CH3, CH2 and NH2. So what it is primary amine we are getting. Okay. So primary amine. So what is the options? Option 1 is the correct option. Yeah, option 2, 3 and 4 are different. So we will get option 1. Question number 66. For question number 66, what is Z in the given reaction? Okay. So we here have a compound here. It is known as this is okay, sorry, we don't have to name it. Okay, so what type of alkene is there? It is unsymmetrical alkene, right? So the unsymmetrical alkene on reaction with HBr and hydrogen peroxide. So what will happen here? This hydrogen peroxide will form CH3, CH2, CH2, CH2 and Br. Okay, Br. So this reaction is also known as what? Kharash effect. Yeah, Kharash effect or the peroxide effect. Okay, because hydrogen peroxide is involved. It is also known as the peroxide effect. Yeah. So on reaction with again on reaction with C2H5ONA, we will get the compound Z. So what will happen here? C2H5O. Okay, wait. C2 C2H5O. Okay, this will have negative polarity and this will have positive polarity. So what happens? This C2H5O, this will attack here and the bromine will get removed. So what will be the product? CH3, CH2, 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 then O, C2H5. Okay. Okay, if you are not understanding this way, Then I have just written the molecules in the upward direction. Okay, CH3, CH2, 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 then it is O, then C2H5. Okay, like this. So this is the product we are getting. What is the name of the product? This is an ether. Okay, and this process is the name reaction known as Williamson ether synthesis. Remember, this is Williamson ether synthesis. So like this we are getting the product. So which among this is the correct option? Option number 4 is the correct option, right? For question number 67, yeah. For question number 67, considering the formation, breaking and strength of hydrogen bond, predict which of the following mixtures will show a positive deviation from Raoult's law. Okay, so here see. The molecules, okay, the answer will be first one because let's discuss it. The molecules in pure methanol are hydrogen bonded. Okay, methanol will have hydrogen bonding in its molecule. When we add acetone, the molecules of acetone will enter in between the molecules of methanol. Okay, and break some of the hydrogen bonds. Therefore, the intermolecular attractive forces between the solute-solvent molecules are weaker than those of the solute-solute molecules and solvent-solvent molecules. Okay. So, what will happen that on adding acetone, the hydrogen bond between the methanol will be break. So, it will show a negative deviation in the Raoult's law. So, here it is asked only which will show the positive deviation. Okay, it should be negative deviation. Okay. Oh, sorry. Ah, sorry. It will show a positive deviation. Yeah, it will show a positive deviation in the Raoult's law, and in the other three will show the negative deviation in Raoult's law. Okay. Yeah. So for question number next is for question number 68. The question number 68 is a matching type reaction. For the match type reaction, what you have to do, you have to remember some of the theory parts at least, because the matching type reaction will come directly, okay? Like what is the order of the reaction. So if you remember the examples of the order of reaction, then you will uh, solve this easily, okay? So like this, phenol. What type of reaction phenol show? It shows the Reimer-Timer reaction. Okay. What type of reaction will the acetic acid show? It will show the Hell-Volhard-Zelensky reaction. The formaldehyde will show the Cannizzaro reaction, and toluene will show the Etard reaction. So according to this, which option is correct? Option 4 is the correct answer. Okay. For question number 69. In the question number 69, the EMF of the given cell 2Ag plus Cu gives Cu2 plus and 2Ag. The E naught of Ag plus is given minus 0.8 volt, and the E naught of Cu plus 2 and Cu is given 0.3 volt. Okay. So the EMF is given. We have to find the E naught cell is given. We have to find the E cell. Okay. E cell is Ag plus okay. E naught of Ag plus Ag minus E naught of Cu plus 2 and Cu. Okay. So this comes out to be, we have to put the values, and the answer comes out to be 0.5 volt. Okay. So this is the most easiest question. Question number 70. Which of the following complex ion is expected to absorb visible light? So for visible light absorption, we have to, we should know that the d orbitals, okay, the d orbitals, if it contains 0 electrons or 10 electrons, then what happens? If it contains 0 electrons or 10 electrons, then it will be colorless, okay. So for the compounds to absorb light, the d orbitals should not contain 0 or 10 electrons. Otherwise, it can contain any number of electrons and it will show visible light. It will absorb visible light and will appear as colored. Okay. Absorb visible light or it should be colored. So let's see. For titanium 1, the T plus 4 electrons it will have 0, 3D 0. So it will not show color. It will be colorless in nature. For chromium, chromium plus 3 will have 3D 3. So it will be colored. Okay. This will be colored. For zinc, I have said that for the 3D orbital should not be fully filled. Okay. So this also will be colored, and scandium it is 3D 0. So it is also colorless. Oh, sorry, Zn plus 2 is colorless. Yeah. So the correct option will be chromium. Okay. The chromium compound will be colored. So this is the correct answer. Question number 71. The assertion says the melting point of parachlorobenzene is greater than orthodichlorobenzene. Okay, and the reason is paradichlorobenzene is more symmetrical than orthodichlorobenzene. So we have to find the assertion and reason. So yes, obviously this reason and assertion and reason is true for the given compound. Why? Because the structure of let's draw the structure of parachlorobenzene first. Okay, paradichlorobenzene. So this is paradichlorobenzene, and then we have to draw the structure of orthodichlorobenzene. Okay, so this is orthodichlorobenzene. So the reason is there, it has high melting point because it is more symmetrical in nature. So yes, it is symmetrical because if we draw the line of symmetry in the middle, this is the middle, okay. So it will be symmetrical in nature, which is why, okay, you can't see this now. Yeah. So parachlorobenzene is symmetrical in nature and it has the high melting point. Therefore, it will have a high melting point. So option assertion is the reason is the correct for assertion, right? So option 1 is the correct option. For question number 72, given below are two statements. Lucas test primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with conc HCl and ZnCl2 known as Lucas reagent. Okay. Statement 2, primary alcohols are most reactive and immediate produce turbidity at room temperature on reaction with Lucas reagent. So here we note that Lucas test, what is Lucas test? It is used to distinguish or differentiate between HCl and it is used to distinguish between primary, secondary and tertiary alcohols. Okay, and what is the reagent here? HCl and anhydrous ZnCl2 is used as a Lucas reagent. So tertiary alcohols will give immediate turbidity at room temperature. This will be the only tertiary alcohol is the only one which will give turbidity immediately. The secondary alcohol gives turbidity 5 minutes at room temperature and the primary alcohol does not give turbidity at the room temperature. Okay, so alcohols are versatile compounds. Okay, leave this one. So what will be the correct option? Statement 1 is correct, but the statement 2 is the incorrect one. Okay, statement 2 is the incorrect one. For question number 73. For question number 73, identify in the column 1 and their corresponding options in column 2. Okay, question number 73. For CrH2O whole 6 plus 3, hybridization of unpaired electron is D2sp3 and the unpaired electron is 0. Okay, let's see. The correct option will be, okay, let's leave the option. We have to find it first. What is the explanation? Okay, so in CrH2O whole 6 plus 3, the chromium is in the plus 3 oxidation state. Okay, chromium is in the plus 3 oxidation state, so it has the 3 unpaired electron in the D shell. So in 3D there is 3 unpaired electrons, but in the option it is written it has 0 unpaired electrons, but it is not correct. It will have 3 unpaired electrons. Okay, so identify the mismatches. Mismatches we have to identify, so only A is the mismatched option. If we find out the other three will be the correct one. Okay, so for question number 74, for the reaction, the correct statement C2H2 on passing through red hot iron tube at 873 Kelvin, we will get a product A. Then on reaction with CH3COCl and AlCl3, we will get B. So the first reaction yields benzene. Okay. So when C2H2, it is the ethine. On reaction with red hot iron tube, it will give us benzene. Okay. So option A here is the benzene. So on benzene, when benzene undergo reaction with CH3COCl and AlCl3, what we will get? This reaction we will get. Okay. So option B, CH3COCl. What is the name of CH3? Okay, it is CH3. What is the name of this compound? This is acetophenone. This is acetophenone. Okay. So acetophenone does not give sodium bisulfite test. So it will not give sodium bisulfite test. Okay. It will react with 2-DNP and give iodoform test because of methyl carbonyl group. So it will give iodoform test. So what will be the correct option? Option 3. Okay, it will give yellow PPT with iodine and NaOH. This will be the correct option. Question number 75. Which of the following elements does not exist in aqueous medium as species like tetrahedral and octahedral? Okay, so species like MOH whole 4 minus and octahedral does not exist in case of boron due to non-availability of orbitals for expanding its covalency. Okay, so because MOH whole 4, this is tetrahedral and this is octahedral, right? So these does not exist in case of boron. In case of boron, they both will not exist due to the unavailability of orbital. Boron does not have empty d orbitals, okay, so it will not expand. So boron will be the correct option. Option number 76. The filling of 4f before 5d orbitals result in a regular decrease in atomic radii called. Question number 76. The filling of 4f orbital before 5d orbital result in a regular decrease in atomic radii. It is called lanthanoid contraction. Okay, it is called lanthanoid contraction. So lanthanoid contraction is the correct option, and it essentially compensates for the expected increase in atomic size while increasing atomic number. So these both are compensated in lanthanoid contraction. The next question is question number 77. 4 Faraday of electricity is passed through a solution of CuSO4. The mass of copper deposited at the cathode is. So for cathode, 4 Faraday of electricity is passed. Okay. So 4 Faraday, which means the 4 moles of electrons are there, and the 4 moles of electrons means 2 mole of copper is there. So 2 mole of copper will give 2 into, this is the atomic mass of copper, it will give 127. Okay, so 127 grams is the correct option. This is according to the Faraday's law of electrolysis. Right? How can aniline be synthesized? How can aniline be synthesized? Benzyl chloride and ammonia, reduction of benzamide, phenol and ammonia present in presence of ZnCl2, or benzoic anhydride and ammonia. So on the phenol, when it is reacted with ammonia in the presence of ZnCl2 and 300 degrees Celsius, then it will form aniline. Okay. So what will be the correct option? Third one will be the correct option, phenol and ammonia when it is reacted in the presence of ZnCl2. So the next question is 79. Okay, question number 79, right? Yeah. So we have to identify X. Identify what is X here. So this reaction is a Perkin reaction, okay, and it occurs between the aromatic aldehyde and an acid anhydride in the presence of acid carboxylate. So as the acid carboxylate in is sodium acetate, so the acid anhydride would be acetic anhydride. So this reaction, when the, what is this? This is the aromatic aldehyde. Aromatic aldehyde is there, and what will be formed? It will form, this is an acid anhydride. On reaction, it will form acid carboxylate. No, sorry. Yeah, so option X will be an acid anhydride. And which type of acid anhydride is there? It is acetic anhydride, right? Acetic anhydride. So which option is the correct one? Option B is the correct one. So we are almost half done, right? You have to know what answer should be there. You have to aware of the theory. So just read the NCERT properly and try to remember as much theory as possible, because if the theory questions come and if you have that thing in mind, you can easily choose between the incorrect options. Okay. Which of this is not a monomer for the high molecular mass silicon polymer? So Ne3SiCl, it is not a monomer for high molecular mass silicon polymer. Okay, Ne3SiCl, option 3. Why it is so? Because it generates Me3SiOH when subjected to hydrolysis. Okay, this is the structure. On hydrolysis, it will generate this Me3SiOH. Okay, hence the polymerization reaction just stops after the first step. So this should not be there. This will be only from the dimer. No further polymerization will occur. So therefore, it is not a high molecular mass monomer. Okay, high molecular mass polymer. Option number 81. What does option number 81 says? Which of the given metal ion will have T2G6 and EG0 configuration? T2G6 and EG0 configuration. Yeah. So, due to strong field ligands, the pairing of electrons takes place. Okay. So, the strong field ligands, what does it do? The strong field ligands, the pairing in strong field ligands, the pairing energy is low. Therefore, what happens? The pairing of electron takes place. So what will happen? The electrons from the Eg move to T2G and get paired to form a low spin complex. So here Cn is a strong field ligand. So if Cn is a strong field ligand, then the electrons will first get paired up in the T2G orbital. Okay. So like this it is there, right? This is the T2G and this is the Eg. So there are 6 Cn ligands. So the Cn ligands will get occupied first in the T2G orbitals, okay? Because the pairing energy is low, therefore it will not go in the Eg orbitals first. So this type of configuration T2G and E6 is given by FeCN whole 6 minus 4. This, okay? For question number 82, which of the following will not give carbylamine test? Give a carbylamine test, right? So all the amines, whether it is primary amine, all the given amines are primary amines, right? So these all are the primary amines. So if we draw, this is the simplest, this is the primary amine. Yeah, so this is the 1 degree amine, and this is also 1 degree amine, right? Because it is connected, the branches are there in the carbon. So don't get ever confused that it is a 2 degree amine, okay? Here it is 1H and here it is NH2. So this is the 2, sorry. See, I am also confused here, okay? So just don't do this mistake. This is also a primary amine. And here it is also a primary amine. So all of the given options are primary amine, and thus will give a positive carbylamine test. Okay, so primary amine will only give a positive carbylamine test. So what will be the correct option? Option 4 is the correct option, all of this. Question number 84. A man a man-made white silvery metal radioactive in nature has strong tendency to form oxocations and complexes. It is used as a nuclear fuel in atomic reactor. This metal is, okay. So what is this metal? Options are actinide, lanthanide, representative elements and transition metals. Okay, so we know that the actinoids are radioactive metal and it is capable of forming oxocations and complexes. So option A, actinide, is the correct option here. For question number 84, the rate constant, the activation energy and the Arrhenius parameter of a chemical reaction at 25 degrees Celsius are 3.0 into 10 to the power minus 4 S inverse, 104.4 kilojoule per mole and 6.0 into 10 to the power 14 S inverse respectively. The value of the rate constant at t tends to infinity is. So let's say T2 is equals to T. Let's take T2 is equals to T and T1 is given as 25 degrees Celsius. So we have to convert it into Kelvin. Then activation energy is given to be 104.4 kilojoule per mole. And on converting in joule per mole, we will get this. K1 here is 3 into 10 to the power minus 4 and we have to find the K2. So on using these given equations, given numbers in this equation number 1, we will find the K2 to be 6 into 10 to the power 14 S inverse. Okay, so 6 into 10 to the power 14 S inverse is the correct option. We just have to solve this numerical. Okay, all the values are given and we just have to solve it. In question number 85, the reduction of fructose with sodium borohydride forms two products differing in configuration. And the reason here is given, the chiral carbon is formed due to the reduction of keto group at C2. Okay, this is the question number 85. Yeah. So let's draw the structure of fructose first. So what happens? What is the structure of fructose? It is CH2OH, C double bond O, 1, 2, 3, CH2OH. Okay, here it is OH, OH, H, 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 OH. Okay, yeah. So here what happens, that the C2, number it first, 1, 2, 3, 4, 5, 6. So the C2 carbon contains the ketone group. Okay, so on reaction with borohydride, sodium borohydride, what happens, that it forms two products differing in configuration. So let's draw the two products first. Okay, what happens that okay, we'll come to the reason afterwards. We first have to draw the products. 6 carbons are there here, OH, OH, H and H. Okay, yeah, so this product form is known as mannitol. What will be the next configuration? CH2OH, OH, OH, H, OH, right? So what is the name of this product? It is sorbitol. Okay. So these two configurations are formed. Two products are formed which are different in configuration. So what is the reason? The chiral carbon is formed due to the reduction of the keto group at C2 position, right? So C2, the ketone groups present in the C2 carbon will generate this chiral carbon, okay, due to which it will form the two configurations. So option 1 will be correct, that is the assertion is also correct and its reason is also correct one. Now let's move on to the next question. Question number 86. Question number 86 says the relative lowering of vapor pressure is equal to the ratio between the number of solute molecules to the solvent molecules. Solute molecules to the total molecules in the solution, solvent molecules to the total molecules in the solution, and solvent molecules to the total number of ions in the solute. Okay, so what will be the correct option? Option 2 will be the correct option. Okay, why it is? Because according to Rawls law, a relative lowering of vapor pressure of dilute solution is equal to the mole fraction present in the solution. So we know that the vapor pressure of the dilute solution is equal to the mole fraction, which is also given here. The solute molecules is equal to the total molecules of solution, right? Total mole fraction. The next question, question number 87. We are almost there. We are almost going to complete it. Okay. So let's be with me. Question number 87. What is the reason for the solubility of ethylamine in water? So ethylamine will have the hydrogen bonding. Okay. So let's draw first the structure of ethylamine. Here it is CH2, CH3, okay, and here is the water molecule. The ethylamine structure will look like this and it will form the hydrogen molecule with water like this, okay. So what are these? These are the hydrogen bonding. So formation of hydrogen bonding with water is there, okay. So question number 87 is the correct option. Due to hydrogen bonding, it is soluble in water. For question number 88, the standard electron potential of the three metals A, B and C are given. A, B and C. The standard reduction potential is given here. The reducing power of these metals. So the option will, the one element which will have the greatest reduction potential, the greatest reduction potential, the greatest negative electrode potential is of metal B. Therefore, it will have the greatest reducing power. Okay. So, option B will have the greatest reducing power, then the option C, then option A. So, this is correct. Option 1 is the correct option. Question number 89. The electronic configuration of copper is The electronic configuration of copper 2 is 3D9 while that of copper 1 is 3D10. Identify the correct statement. So the correct statement is the configuration, the correct statement is copper 2 is more stable. Okay, why it is so? Because we know that the electronic configuration of Cu2 is 3D9 while that of Cu1 is 3D10. But because of the smaller size of Cu2, the Cu2 will have the smaller size and it also has the less electrons, okay, which is why it is more stable than copper 1. This question is from DNF block, right? In question number 90, which of the following allotropes of carbon, each carbon atom undergoes sp3 hybridization and linked to 4 other carbon atoms using the hybridized orbital in tetrahedral fashion? So it is asking that which of the allotrope of carbon will have the sp3 hybridization as well as it is linked to 4 other carbon atoms using hybridized orbital in tetrahedral fashion. So we know that the carbon has 3 allotropes, namely diamond, graphite and fullerene, right? So here the diamond will have the crystalline lattice. We all know that diamond will have the crystalline lattice structure, and if we draw the structure of diamond, it comes out to be like this, okay? It will have this tetrahedral type structure, okay? And each carbon atom is sp3 hybridized. So it will be linked to 4 other carbon atoms using the hybridized orbital in tetrahedral fashion. So option 1, diamond is the correct option. Question number 91. Okay, which of the following amines has the highest basicity? So see here, the options are there. Okay, so here the lone pairs are there in the nitrogen atom, right? All the nitrogen atom in the NH2 group will have the lone pairs. But the problem here is that the nitrogen atom which are attached to the benzene ring, these are attached to the benzene ring, but 4 is not attached. So let's talk about these 3 first. So the nitrogen atom which is attached to the benzene is ring like this, right? So it will undergo conjugation, okay? It will undergo conjugation with the benzene ring. So the lone pair present in the nitrogen atom is not available for donation. So these three will have less basicity. But in this case, in option number 4, what happens that this nitrogen is not bonded to the benzene ring. So its lone pair is available for donation, right? Available for donation. So option 4 is the correct option. It will have the highest basicity. Yeah. So let's move on to question number 92. The value of rate constant of pseudo first order reaction depends on. What does it depends on? Okay, question number 92. So pseudo first order reaction, what it is? It is a chemical reaction which depends upon the concentration of only one reactant. Okay, it depends upon the concentration of only one reactant, while the concentration of other reactant will have no effect on the rate of reaction. Like consider this equation, okay, these are the product and these are the reactants. So it will depend upon the concentration of reactants. So in this case, the concentration of this and water, okay, is there. But considering that the water is used in excess in this reaction, so it could be neglected. Okay, the concentration of water could be neglected, so we are left with this rate. Okay, so accordingly, what will be the correct option? The correct option will be option number 2, that it depends upon the concentration of reactants present in excess. Okay, for question number 93. Question number 93. Yeah, the product P in the following reaction. Okay, the product P here, what is there? CH2Cl is there. Okay, methyl chloride is attached to the benzene ring, which on reaction with KCN gives product A, and which on hydrolysis gives product B. So we know that the Cn minus, what will Cn minus will do? It will remove the chloride ion from here, okay, and get attached here. So this will benzyl cyanide is the product A here, and which on reaction with H3O plus 2-phenyl ethanoic acid is produced. So 2-phenyl ethanoic acid is the correct option. For question number 94, the molar conductivity is at infinite dilution of KBr, HBr and CH3COOK are given. Okay, the molar conductivity we have to find of CH3COOH. So let's say that the molar conductivity of CH3COOH comes out to be CH3COOK plus molar conductivity of HBr minus molar conductivity of KBr. So now just put the given values here and the answer comes out to be 390.5. So 390.5 will be the correct option. Question number 95. Question number 95. Which of the following reactions can be used to prepare an ether? Okay. So ether can be prepared when alcohol is dehydrated with dehydrated. Okay. Then we will get ether and water is the byproduct. So Which option will be correct? Dehydration of alcohol. So, okay, these are the direct answers, direct questions that we can solve easily. Okay, most of them are just numerical based questions. You just have to remember the right formula. Okay, and most of them are of theory part. So, if you have read the theory, if you have the knowledge about the theory, then you can easily crack or easily aim for higher marks in the NEET exams. Question number 96. At 100 degrees Celsius, the vapor pressure of solution of 6.5 gram of solute in 100 gram of water is 732 millimeter. If Kb is 0.52, the boiling point of this solution will be, what will be the boiling point? So we have to find the boiling point. First we have to use this formula. The vapor pressure comes out to be W1 by M1 into M2 by W2, where W1 is the weight of the solute, W2 is the weight of the solvent, and M1 is the mass of solute, M2 is the mass of solvent. Okay, and P naught is there. P naught is given to be 760 millimeter. So let's put this value accordingly. On putting this value, we will get M1 as 31.75 gram per mole. Then we have to find the boiling point. So boiling point will be M into Kb, this formula. Using this formula, we will find that delta Tb comes out to be 1.06 degrees Celsius. We have to find the boiling point of this solution, which means that the boiling point of water will also be used. So the Tb and boiling point of water are added, and this we will get the correct option as 101.06. Okay. 101.06, so option 1 will be correct. The next question, question number 97. Okay. So for question number 97, arrange the following carboxylic acid according to their strength of acidity. According to the strength of acidity. Okay. So here the electron withdrawing group will increase the strength of the acid. So we know that the electron withdrawing group, if an electron withdrawing group is present, then what it will do? It will increase the acidity. So here Cn is the electron withdrawing group and Br and Cl is also electron withdrawing group. But let's see. Uh, Electron withdrawing group is there, so accordingly it will have the greatest acidity among all this, okay, because it is also a strong electron withdrawing group. So first one will have the greatest, so option 2 will be incorrect here. Let's try to eliminate the other options first. Okay, so okay, then what happens that this is also electron withdrawing and Cl is also electron withdrawing, but let's see Br is present here. Okay, see the distance among the carbon atoms, it is present here and the COH group is there. So Br will have next greatest acidity from 1 from Cn. Okay, so 4 will be there, so here it is 4. Then option 2 is there and then option 3, so option number 4 will be the correct trend. Okay, option number 3 is uh, at last. Why it is so? Because the chlorine atom is present at a much larger distance. Okay, so therefore it will be less acidic and COH group will be more acidic than the chlorine one. Option 4 will be the correct option. For question number 98, which compound among the following fails to form a silver mirror when reacted with Tollens reagent? Okay, so for Tollens reagent, carbonyl group has to be there. Okay, and this is the compound which will also show Tollens, which will also act with Tollens reagent. Okay, so which will not attack, it is also having the carbonyl group, and this aldehyde also have a carbonyl group. Option 4 will be the correct option because it will not react with Tollens reagent. Okay, it is the amine, primary amine is there. Okay, so option number 99. So we have reached almost last of the questions. I'm sure that you all will be practicing, right? So question number 99, which of the following compound gives the negative Felling's test? So reducing sugar, what are the reducing sugar? Reducing sugar are the one which contains an aldehyde group or a ketonic group and it acts as a reducing agent. Okay, so reducing sugars are the one which gives a positive Fellings test. Positive Fellings test. However, among all monosaccharides and disaccharides, sucrose is only the non-reducing sugar. Thus, it will give a negative Fellings test. Okay, so sucrose is because it is a non-reducing sugar, it will not give a Fellings test, while others are reducing sugar and therefore it will give Fellings test, right? So, question number 100. The structure of diborane contains. So, this is the structure of diborane. It contains how many 2C2E bond and how many 3C2E bonds. Okay. So, this type of structure, we all know that this is the structure. So, the terminal hydrogens which are attached to the boron, which type of bonds it will show? It will show 2C2E bonds. Okay, 2 center, 2 electrons bonds it will show, and the bridged hydrogens. The bridged hydrogens here will show the 3C2E bond. Okay, so how many 2C2E bonds? 4 2C2E bonds are there, 4 2C2E bonds and 2 3C2E bonds, right? So option 1 will be the correct option. Okay. So yeah, we have come to the end of this test paper solving. So I hope you will rectify your mistakes and try to do better in future and keep learning. Thank you.